students, in today's class we are going to talk about computer systems and software. In yesterday's session we talked about IT and society, and we discussed some of the aspects of IT and society, how IT is changing our day-to-day life, and some applications of IT in our day-to-day life. In today's session we will talk about the computer systems and software. To be exact, we are going to cover the first learning outcome in today's session. So without talking further, let's get into the video. So the first learning outcome that we are going to cover in today's session is this one. We have to understand the components of a computer system. So what are the assessment criteria? So these are my assessment criteria. After finishing this lecture, the learner or the students are supposed to describe the components of a computer system. As we all know that computer consists of different components, so we are supposed to learn the basic terminologies and basic applications, and I should say the basic applications of all those components after completing this section. Next up, we are supposed to analyze networking infrastructures. Then we are supposed to assess the function of components within a chosen computer systems. Then evaluate peripheral devices to meet different purposes. So okay, so these are the learning outcomes that we are supposed to cover. I have made a PowerPoint presentation for this one. So without talking further, let's get into that one. But I should give you a disclaimer that some of the contents might not be directly included in the PowerPoint presentation. It is actually sometimes I did it, I discarded some of the information so that you can work on it, so that you can go through some of the reference books and then you can find it out whether this thing is given or not. Okay. So without talking further, let's get into the PowerPoint presentation. So this topic is all about the computer systems and the software. Okay. So these are the contents that basically I'm going to cover. First, we will start off with the basic concept of networks. Then we will discuss about the uses of networks in sharing resources, backups. Next up, we have common types of networks. We all know there are different kinds of networks such as LAN, WAN, Internet, server-based connections, client-server model, and P2P. Next up, we have network media. Then we have wireless networks. We will also talk about threats to network. What are the threats and how we can minimize those threats? We will talk about that. And next up, we have the internet world, how the internet is working, what are the functionalities, how it is, it is operated. These are the things that we are going to discuss. And finally, we will wrap up our today's presentation with cloud and cloud computing. Though it's not under the scope of today's learning outcome, still we will talk about this one. And some of the contents might not be directly related to the learning outcome, but I have included that so that you get a better understanding of the network system itself. Okay, anyways, so the computer network. So a computer network is a group of computers. What is it? It's a group of computers or devices. You can in most of the cases it is called a node. So a computer network is a group of computers or devices that use a set of common communication protocols over digital interconnections for the purpose of sharing resources located on or provided by the network nodes. So what do you understand by that? So simply there are two terms actually. There are three important terms here. The first one is the node. So if I ask you what is a node? Node is a computer, you can say it's a group of computer or devices. When we have a group of computer or devices connected together, then it can be called as a node. So a group of computers or devices that use a set of common communication protocols over digital interconnections for the purpose of sharing resources located or provided by the network nodes. So this is what called a computer network. So say for example, if I think it's very familiar to you, this term is might be very familiar to you. If you don't have idea, let me explain with some basic real life example. Let's say there are three friends. You have three friends and you are standing in a queue, and the first person from the back is supposed to pass an information to the second one. The second person is supposed to pass the same information to the first person. So how will this communication take place? The third person may whisper to the second person's ear. The second person will do the same to the first person. So this is how the protocol is going on, right? This is how this is how a communication is happening. The same goes for computer networks as well. When some computers are connected together, there might be some protocols through which they are supposed to pass information from one place to another. Understood? I hope you have understood. The next up, we have the nodes of a computer. A network may include personal computers, servers, networking hardware, or other specialized general purpose hosts. So nodes of a computer may include personal computers, servers, networking hardware, other specialized. We all are familiar with computers. Servers we might have heard. If you don't have heard, don't worry. Server is a set of computer. You can say, sometimes I will not use technical terms, rather I will use some general purpose terms that will help you better understand. So you can consider server as a big computer where all of the information, a large number of information or bulk information is stored. So server can be considered as a big storage device. Next up, we have the networking hardware. Right. So networking hardware is a device that is used for networking purposes, or next up we have other specialized general purpose host. The interconnection between nodes are formed from a broad spectrum of telecommunication network technologies based on physically wired, optical, and wireless technologies. Finally, they are saying that a communication protocol is a set of rules for exchanging information over a network, physically wired, optical, and wireless. Fair enough. So this is the network diagram. If you look closely, you see that here is this is the internet. Then the internet is connected to a router, or you can say a router is connected to the internet, and there is a firewall connected to the router, and then there goes a line, fiber optic network line, and through this fiber optic network cable, our devices, say for example our PCs, wired networks, printers, servers, all of these things are getting connected. So this is how a network is connected internally, you can say. This is a network diagram. I think you might have seen it before. If not, I would suggest you to understand it. Okay. Okay. Next up, what are the advantages or uses of network? So simultaneous access. So there are moments in any business when several workers may need to use the same data at the same time, right? It usually happens in the office environment. So simultaneous access might be needed. So shared peripheral devices or personal communication. So these are some of the advantages. The personal communication, video conferencing, voice over internet protocol. VoIP transmit the sound of a voice over a computer network using the internet protocol rather than sending the signal over traditional phone wires. Okay, I can give one example of this one. I hope you guys are familiar with this term, VoIP. If not, no problem. So back in 2019, when I was in China, I used to call my parents using a VoIP dialer. It was actually from Reef Systems, and VoIP dialer. What do they do? they actually convert the voice signal. They actually transmit that voice signal over a computer network, not through the traditional wireless or the mobile network. No, they don't do that. They actually transfer the signal, the audio signal, through a computer network. So this is what they do. So yeah, is your data backup. Okay, anyways, so let's move on to the next one. So networking devices, these are the different components of a networking devices. First up we have an NIC card. Next up we have a repeater. Then we have hub. There is also switch, bridge, router, gateway, and firewall. Most of the terms might be familiar to you. You might not have heard of this term, repeater. What is a repeater? It's your duty to find it out. So the most of the term in IC card you might have heard. Hub. We use hub in our day-to-day life. It's a very common, I should say, it's a very common peripheral device. It's a very common device. Mostly we use USB hubs for connecting multiple devices into same USB hub, right? You might have seen it. Switch, what is a switch? If you don't know, we will talk about it. Routers we have seen, gateway and firewall. We already talked about these two terms in our previous slides. Fine. Next up we have the first component was network interface card. The network interface card looks like this, and usually it is called NIC. So NIC is used to physically connect host devices to the network media. What is meant by that? NIC is used to physically connect host device to the network media. What do you understand by this one? Tell me. Pause the video for let's say 20 seconds, think about it, and share your thoughts on this. Okay. Next they are saying an NIC is a printed circuit board that fits into the expansion slot of a bus on a computer motherboard. It can also be a peripheral device. NICs are sometimes called network adapters. Yeah, they are sometimes interchangeably used. It can also be called as a network adapters. Okay, next up we have each NIC is identified by a unique code called a media access control address. Okay, each NICs will have a specific media access control address. You have to understand this one. Okay, media access control device. So this address is used to control data communication for the host of the network. Is it understood? MAC address. What is a MAC address? Each device has its specific MAC address as well as media access control address as well as an internet protocol IP address. So we have already told here that each network interface card is identified. It is actually for the identification purpose. So each NIC is identified by a unique code that is called a media access control address. Okay, then we have repeaters. A repeater is a network device used to regenerate a signal. A repeater is a network device that is used to regenerate a signal. Repeaters regenerate analog or digital signals that are distorted by transmission loss due to attenuation. A repeater does not make an intelligent decision concerning forwarding packets. A repeater is a network device used to regenerate a signal. Fair enough. Repeaters regenerate analog or digital signals that are distorted by transmission loss due to attenuation. So it's your duty to find out what is attenuation. I request you to search that on Google and then tell me what do you understand by attenuation. But the main point is this one. Repeaters are usually used for regenerating analogs or digital signals that are distorted, somehow got distorted, and the repeater is actually trying to regenerate the signal. So if somebody asks you why repeaters are used, for what purpose, you should say that repeaters are actually used for regeneration purpose for a signal which gets distorted somehow. I hope this is understood. Let's move on to the next one. Next up we have hubs. So hubs concentrate on connections. In other words, they take a group of hosts and allow the network to see them as a single unit. This is done passively without any other effect on the data transmission. So active hubs concentrate hosts and also regenerate signals. So in the previous slide also we were telling that repeaters, right? Repeaters were used for regenerating signals that was somehow distorted. In this case also, in one of the points we are telling that the hubs concentrate on connections. In other words, they take up a group of hosts and allow the network to see them as a single unit. So this is done passively without any other effect on the data transmission. So active hubs concentrate on hosts and also regenerate signals. So I hope this part is also understood. Next up we have bridges. So as you can see here, all these three PCs are firstly connected to a hub, then this hub is getting connected to a bridge, then this bridge is connected again with another hub, that hub is connected to three other PCs. So this is the working principle of a bridge. So bridges convert network data formats and perform basic data transmission management. So why it is being used? You can say the bridges are actually used for data transmission management, and bridges provide connections between LANs. Right, bridges, this is an important point that you need to memorize. I shouldn't say memorize, I should say this is an important point that you need to keep in mind. So bridges provide connections between LANs. They also check data to determine if it should cross the bridge. This makes okay, give me a minute. Seems like there is a network problem. Okay, we are back online. Okay, so bridge actually provide connection between LANs. They also check data to determine if it should cross the bridge. This makes each part of the network more efficient. They also check data to determine if it should cross the bridge. So every time they are actually checking the data whether it should cross or not, right? So this is one of the purpose of a bridge. It actually continuously keeps on checking. It keeps on checking the data, so whether the data should be crossed through the bridge or not. Here is the bridge. As I have told you before, that the bridge is connected to the hub. Anyways, let's move on to the switches. We talked about hubs, we talked about bridges, hubs. Now we are in switches. So switches add more intelligence to data transfer management. So they can determine if data should remain on a LAN and transfer data only to the connection that needs it. Another difference between a bridge and a switch is that a switch does not convert data transmission formats. Is it understood? So we can say switch is an intelligent device, bridge is not. So both serves the similar kind of purpose, but they are kind of similar in nature. But switch, you can say it's an intelligent device. It can change the format of the data. This is how it is different from the switch. So this is one important point you should understand. So another difference between bridge and a switch is that a switch does not convert the data transmission formats. Okay, next up you have routers. Okay, so routers have all the capabilities listed above. So routers can regenerate signals, concentrate multiple connections, convert data transmission formats, and manage data transfers. Now it's your turn to make me understand what you have understood through this line, by this line. So routers can regenerate signals, concentrate multiple connections, convert data transmission formats, and manage data transfer. What is understood by this thing? What do you understand by this? It's your duty to tell me. It's your duty to tell me. Okay. Next up, we have they can also connect to a WAN, which allows them to connect LANs separated by great that are separated by great distances. They can also connect to a WAN, which allows them to connect LANs that are separated by great distances. Fine, fair enough. Next up, we have gateways. A gateway, if we observe carefully, we see that there are different PCs. Here's the gateway, right? Here's the gateway. We have a server over here. There is another server here. So gateway is a piece of networking device used in telecommunications for telecommunication networks that allows the data to flow from one discrete network to another. So this is one network. You can say this thing is a one network. This can be considered as a one discrete network. This can be considered as another discrete network. In between them there is a gateway. So a gateway is connected to the server on both the ends. So it is being used for what? For transferring data, obviously, between one discrete network to the other. I hope it is understood. So gateways are distinct from routers or switches in that they communicate using more than one protocol to connect a bunch of networks. So gateway can connect with a bunch of networks using a multiple protocols. So you can say, I told you before that the switch is an intelligent device. So in general terms, we can say gateway is more intelligent compared to the other devices that we have discussed before. We can say that. Next up, we have firewalls. A firewall is a network device. Is a network device or software for controlling network security and access rules. So firewalls are inserted in connections between secure internal network and potentially insecure external networks such as the internet. So firewalls are typically configured to reject access requests from unrecognized sources while allowing actions from recognized ones. So what is told here? What do you understand by these lines? So firewalls are typically configured to reject access requests from unrecognized sources while allowing actions from recognized ones. So firewalls are what? Firewalls is a device that in general terms we can consider firewall as a security guard of, let's say, of an organization. Security guard of an organization. What does he do? He doesn't allow the visitors to enter into the office compound if the visitor is not well recognized. If his identity is not recognized, the security guard is not going to allow the visitor to enter into the office compound. But if the person is recognized, if he is on, let's say, if he has some identity card with him, and if he has some contacts, and if he has some purpose to meet, let's say, meet the higher officials of this of that office, then after recognizing him, after collecting all his documents, after verifying, then maybe the security guard will allow him to enter into the office compound until and unless the identity is revealed, until and unless the identity is verified. The security guard is not going to allow that visitor to the office compound. The same goes for the firewall as well. So firewall will only allow recognized what? Firewalls will typically allow typically allow access to allow data transmission from recognized devices. Unrecognized devices will not be allowed. This is what the firewall does. The vital role of firewall plays in network security grows in parallel with the constant increase in cyber attacks. So nowadays cyber attacks is on the rise. Sometimes even some private organization, even some government organizations website is getting hacked. as there is network security, I mean there is a potential threat to the network security, organizations, both public and private, are giving priority to the um, I should say the firewall management these days. Next up, we have network media. Okay, a function of the media is to carry a flow of information through a LAN. First up, we have wired media. It's a widely adopted family that uses copper and fiber media and local area network technology, are collectively known as Ethernet. We all know this, right? If you are using a desktop connection, and if you are connected to the internet, I would suggest you to have a look at the back side of your computer. You will get to see there is a Ethernet cable over there. So mostly that might be a copper cable. So copper cable, it can be classified into three terms. First up we have the coaxial cables. Next up we have the shielded twisted pairs, that is called STP, and finally we have unshielded twisted pairs. So these are the three common option that comes under the umbrella of copper cable. Next up we have fiber optic cables. Sometimes we use this one as well. Okay, then we have wireless media as well. So it uses the atmosphere or space or the medium. Wireless media, what is that? It's your duty to find out. Uh, let's say when we are using the modem, internet modem back in 2000, let's say 2010, right? 2010-15, we were solely reliant on network modem or internet modem, mostly by the I mean there was one service, mobile service provider, that was called Grameenphone. They had a device for Grameenphone modem. So most of the people back in 2010 to 2015 used those modems to get connected to the internet. So that can be considered as a wireless medium. Anyways, well, we were talking about copper cable. So copper cable looks something like this. As you can see, this is 10 base 5 thick net, 10 base 2 thin net, and we have 10 base T. People use these things, I mean these cables, for connecting to the internet these days, especially in rural areas. Rural and urban areas, they use this kind of cables. Okay, the most common, easiest, quickest and cheapest form of network media to install. The disadvantage of sending data over copper wire is that the further signal travels, the weaker it becomes. Yeah, it's true. This is one of the disadvantages of copper cable. The more the data has to travel, the less the signal becomes stronger, or the signal becomes weaker by the passage of time. So is the copper cable efficient? To some extent, no, not that efficient, but we are usually using it for the ease of access, ease of availability, and nominal cost. That's why this thing is still in use. Next up we have coaxial cable. It can be run longer distances than twisted pair cable. So its speed can be from 10 to 100 Mbps. The cost is not that expensive, it's inexpensive. Then we have media and connector size is medium. Medium. Maximum cable length is 500 meters. This is one of the properties that you should keep in mind. Okay. Next up we have shielded twisted pairs, often denoted as STPs. The speed is from 0 to 100 Mbps. Usually the range is in between 0 to 100 Mbps. The cost is moderate, and media and connector size is medium to large, and maximum cable length is 100 meters. So as you can see, there are different parts of it. First we have the jacket. Underneath that one we have the braided shield. After that we have foil shield, and next up we have the twisted pairs. So this is how the twisted pairs looks like. There are two pairs of you should say wires that are twisted together. So there is a twisted pair of cables here. Unshielded twisted pair. Unshielded twisted pair. What is that? Unshielded twisted pair. Sometimes it is called as UTP. UTP is a 4-pair wire medium used in a variety of networks. Each of the 8 copper wires in the UTP is covered by insulating materials. Fine, good enough. So it protects the copper wire from physical damage. It's the outer jacket. Here we have it protects the signal from interference. Twisted pair. Fine. The speed is actually from 10 to 100. The speed is from 10 to 100 mbps. The cost is, it's actually least expensive. Media and connector size is small. Maximum cable length is 100 meters depending on the quality or category of the cables. Depending on the quality of the category of the cables, it's like 100 meters. So what is written over here? It protects the signal from interference. This twisted pair. Okay, fine. Okay, this is how UTP is implemented. You might have seen it in your homes. If you are using a broadband connection, you might have seen it. This is how it looks like. So EIA or TIA specifies an RJ45 connector for UTP cable. RJ45 connector. What is that? This thing, this transparent thing is called an RJ45 connector. It is connected to the UTP, unshielded twisted pair cable. You must have seen this if you are using a broadband connection in your home. So the letters RJ stands for registered jack. Fine. Next up we have the fiber optic cable. Glass fiber carrying pulses, each pulse a bit. Okay, fiber optic. This is how a fiber optic cable looks like. It is based on the total internal reflection of a light. Light is passed through this one, and based on the reflection, it will be providing you with some sort of data output. So high speed point to point transmission. Unlike the previous connections, here the transmission speed is very high, from 10 to 100 Gbps. We have low error rates. So repeaters spaced far apart. So immune to electromagnetic noise. Yeah, it's immune to electromagnetic noise. Find the communication protocol. So internet protocol suite of, it is also called TCP/IP, is the foundation of all modern networking. It defines the addressing, identification, and routing specification of for IP version 4 and IP version 6. It is the defining set of protocols for the internet. This is another protocol that is called IEEE 802. It is a family of IEEE standards dealing with local area networks and metropolitan area networks. They operate mostly at level 1 and level 2 of OSI models. We haven't get into the OSI models. We haven't get into the operating systems yet. In next class. Next class means on next week we will talk about the operating systems and different layerings and models. Next class. Next up we have Ethernet. It is a family of protocols that is used in wired LANs described by a set of standards together called as IEEE 802.3. Okay then. And finally we have the TCP IP protocol suite. Here as you can see, OSI models, these are my OSI models and layers. This slide will be provided to you. I suggest you to go through this one, and this will be discussed in our next class in great details. Some communication protocols are given over here. So these are my types of networks. I will try to wrap it up quickly. So first we have personal area network, we have local area networks. There is a thing called campus area networks, which is usually used on campuses such as the colleges or universities. Next up we have metropolitan area network, wide area network is there, storage area network, SAN. Next up we have virtual private network, client server network, and peer-to-peer network. These are the networks that we have. So what is a personal area network? A personal area network is a computer network used for data transmission amongst devices such as computers, telephones, tablets, and personal digital assistants. Right? It's a computer network. So if there is a network where data transmission is, computer network used for data transmission amongst devices such as, you can say it's a computer network used for data transmission amongst personal devices. That's it. Personal devices. What are personal devices? You may have personal computers, you may have personal telephones, tablets, and personal digital assistants. So these are the personal devices that we have. So personal area network is a computer network where transmission, it's a computer network used for data transmission amongst personal devices. Sometimes it is also called home area network, which is denoted with HAN, HAN. So PANs can be used for communication amongst the personal devices themselves. So interpersonal communication can also be done, or connecting to the higher level of network and the internet, where one master device takes up the role of as the internet router. Right? So we can say that all these devices can connect, all these devices may transfer data from one place to another, or these devices may transfer data from one place to another. No, we shouldn't say that. These devices may transfer data internally, or these devices might be connected to a master device, let's say to a router, and router takes the responsibility of transferring the data to different devices. That's what they are actually telling. Next up we have local area network. So Xerox Corporation worked in collaboration with DEC and Intel to create Ethernet, which is the most pervasive LAN architecture used today. So Ethernet has evolved and has seen significant improvements in regard to the speed and efficiency. An upside of a LAN is fast data transfer with a data speed that can reach up to 10 Gbps. Other significant LAN technologies are fiber distributed data interference and token ring. Right? Other significant LAN technologies are fiber distributed data interference and token rings. Next up we have the campus area network. It is larger than LAN but smaller than metropolitan area networks. So if we look closely in this picture, you may understand this one. So it is larger than LAN but smaller than MAN. And networks, these types of networks are typically seen in universities, large K2 schools, districts, and small businesses. So as I told you before, this is where campus area network is being used. Next up we have the metropolitan area network. A MAN is a larger than a LAN but smaller than or equal size of a WAN. So the size range anywhere from 5 to 15 kilometers in diameter. So this is what you need to keep in mind. 5 to 15 kilometers in diameter. So MAN are typically owned by and managed by a single entity. What they are actually trying to say, the MAN is typically owned by and managed by a single entity. This could be an ISP or telecommunication company that sells its services to the end users in that metropolitan area. Right? It's a big organization, or you can say it's a big corporation who is owning that total coverage, and they are actually selling it, could be selling its services to the end users in that metropolitan area. Wide area network, what is that? A wide area network exists over a large area. Data travels through telephones or cable lines, usually requires a modem. The world's largest wide area network is the internet. Yeah, that's true. Okay then, so uh, okay, we will not get into the topologies. Topology is not included in today's session. So you are supposed to write down an assignment consisting 1000 words on the topics that I have covered today. And as I told you before, that these are the learning outcomes that you are supposed to cover in your assignment. You have to describe the different components of different computer systems, then analyze networking infrastructures. Yeah, we have talked about this one. Different infrastructures we have already discussed. Next up, you are supposed to assess the functions of components within chosen computer systems. Functions of components within a chosen computer systems. The final one is evaluate peripheral devices to meet different purposes. Next, you have to evaluate peripheral devices to meet different purposes. What are the peripheral devices? We have discussed different peripheral devices such as hubs, routers, switches, firewalls. So most of the things has already been covered. It's your turn to wrap it up in a proper manner. Write all these things one by one. There are four sub. There is one specific learning outcome. Underneath that one, there are four subdivisions. There are four parts. So in your assignment, you have to include all these four parts in four paragraphs. Write these things in four paragraphs, and within that four paragraph, you might have different points. That's not a problem. Anyways, so we were talking about the storage devices, not storage device, storage area network. So SAN may be referred to as a sub network or a special purpose network. So its special purpose is to allow the users on a larger network to connect various data storage devices with clusters of data servers. What does that mean? Its special purpose is to allow users on a larger network to connect various data storage devices. So there are multiple data storage devices. SAN allows the users on a larger network to connect various data storage devices with clusters of data servers. As you can see, there are, if you observe this one, as you can see, they are actually connected together. So SAN can be accessed in the same fashion as a drive attached to the server. So storage area network can be accessed in the same fashion as a drive attached to the server. Virtual private network, we are actually familiar with this term. Mostly we are familiar because we are using VPNs in our day-to-day life. Usually it is being used when some services are unavailable. Let's say when I was in China, some of the sites were blocked, such as Google. Google was blocked. I was not able to access Google. I was not able to access Facebook. So for accessing those sites, what people usually do is they use VPNs to access those sites, and then for accessing those sites they use those VPNs. So VPN is nothing but a private network. It's a private network that can access public networks remotely. So VPN uses encryption and security protocols to retain privacy while it accesses outside resources. So as you can see, here is a VPN server. Here is the VPN client, right? Here is the VPN client, right? So when employed on a network, VPN enables an end user to create a virtual tunnel to a remote location. Typically, telecommuters use VPN to log in into their company network from home. So as you can see, there is a tunnel. Through this tunnel, actually my VPN client is accessing that VPN server, right? And as you can see, they are telling that the authentication is provided to validate the identities of the two peers. Confidentiality provides encryption of the data to keep it private from prying eyes. Not praying, it's prying. Prying eyes. Integrity is used to ensure that the data sent between the two devices or site has not been tampered with. Yeah. So as you can see, there is a VPN client, there is a tunnel. Through this tunnel, it is actually accessing the VPN server, and then they are actually connected to the device that they are trying to fetch the data from. So this is how the VPN is actually working. Next up, we have the client server networks, and this will be the last topic for today. So in client server network, in a client server arrangement, network services are located on a dedicated computer called a server. The server responds to the requests of a client, as you can see here. In a client or server arrangement, here is the server that we have. This is a server. The server responds to the request of the clients. These are different clients. So the client will send different requests. After getting the request, server will respond to the request that the client has sent. The server is a central computer that is continuously available to respond to requests from clients for file, print, application, and other services. So when a client is telling, let's say this computer is telling the server to print something, so that actually means that client is sending a request to the server to print a document. The server will respond whether it is possible to print or not. So most network operating systems adopt the form of client or server relationship. Typically, desktop computers functions as clients, and one or more computers with additional processing power, memory, or specialized software functions and servers. So most of the topics has already been covered in today's session. I tried to cover all the learning outcomes that were given in the syllabus. If something is not understood, feel free to let me know. Let's end our today's discussion here. We will meet again next week for the next class, and we'll talk about IT and societies, second learning outcome in next class. Until then, take care, stay safe, and goodbye.